Hi all. This is 12.2 solubility. We're going to be talking about solubility curves especially. Now guys, this is all about solutions. So this is when you have tiny particles that we say they dissolve because you can no longer see the differences between them. These are homogeneous in nature. Homogeneous, I can never spell that right. Alright. Now, dissolving occurs at the surface of the solute. So, when I pour my sugar into my tea, here are my little sugar pieces, they dissolve from the surface of each little piece of sugar in. Now, there are three things we can do. We can make the chunks of sugar smaller, so instead of cubes, you do little granulated sugar. Stirring or shaking, you need to write that in. Obviously we stir things because that helps it to dissolve faster. And we can heat it up. Anytime you're making sweet tea, you don't want to try to dissolve sugar into cold tea. It needs to be hot because that makes the particles move faster and opens up the surface area. So, what is solubility? There is a limit to the amount of solute that can be dissolved. This is called a solubility, and it's just an amount. The point at which the limit is reached for how much solute you can pour into a solvent or how much sugar we could put into the tea or the water depends on three things: the type of solute, the amount of solvent, and again, the temperature. So guys, if I had a glass here, and this is hot tea. I'm going to make hot tea now. So here's my mug. Now, I can pour sugar in, right? And it's going to dissolve. It'll be here, and I'll stir it in, and then eventually it'll all be dissolved. If I continue to add sugar into my little cup here, eventually I'm going to hit a point where I can no longer add sugar. It will no longer dissolve. It'll just settle at the bottom. Okay? So that's what we're talking about here. How much sugar can this water take? What's its solubility? A solution that contains the maximum amount of dissolved solute is called saturated. So that one point when I pour in enough sugar into my cup here, and it's the most it can take, it's called saturated. If more solute is added, it falls to the bottom of the container and will not dissolve. Okay, you guys may have seen this when you're making a large pitcher of tea. Okay, we're making a huge pitcher, so it's got some sort of a lip on it or something. And it generally works better with hot water. You pour your like 2 cups of sugar in. But if you pour too much sugar, or if you don't have your water warm enough, you get a layer of sugar at the bottom. That is called supersaturated. The rest of that solute falls straight to the bottom. If it doesn't have enough, if we haven't reached that maximum amount yet, it's called unsaturated. So you've got perfectly saturated, you've got supersaturated, which is right here if you add too much, supersaturated, and you've got unsaturated. Okay, so usually when a saturated solution is cooled, that excess, that too much, comes out of the solution, and it'll still say saturated, and you could just filter out the extra. Alright. But sometimes it forms a supersaturated solution. Here, you put too much in, and this is how we make rock candy. Okay, you have I'm going to show you a picture in the next one, but you have a supersaturated, or you have a saturated liquid here, and you're going to add in a little bit more, and you're going to see what happens. This is my saturated solution, and you see that's one more granule of sugar that's about to be dropped in. When it does that, it forms this network here. It forms a network that will attach. You see how they put a string in? When you put a string in, it gives something for this sugar network basically to attach to, and that's how you make rock candy. Okay, so this solubility that we talked about is the amount of substance required to form a saturated solution. So we're just looking for that perfectly saturated point. Now, this is always with a specific amount of solvent at a specific temperature, okay? Generally, it's for every 100 grams of water at 20 degrees Celsius, okay? So for sodium chloride, or NaCl, sodium chloride, 1-to-1 ratio, because this is a +1, this is a -1, I can put 36 of grams into 100 grams of water at 20 degrees Celsius and it will be perfectly saturated. So here, guys, you're not going to be asked to find the solubility unless I give you the graph here in a minute, but you can find these in tons of books, and they're usually per 100 grams of solvent, and it's usually about 20 or 25 degrees Celsius. Here's an example of solubilities. So look here at 0 degrees Celsius. We could put 1.5 grams of lithium carbonate into 100 grams of water. We could fit, look down at sucrose, almost 180 grams, and it would still dissolve at 0 degrees Celsius. That's pretty crazy, right? So these are all amounts of sugar or sucrose that we could put in to water. Notice when the water's boiling over here at the right, I can put almost 500 grams of sugar into 100 grams of water because the temperature is so high. I can fit more in and it will still dissolve. Pretty crazy, right? That'd be some super sugar water. So we were talking about the temperature. Usually, increasing temperature increases solubility. You warm up your solvent and you can dissolve more solute into it. Now, the effective temperature is difficult to predict. The solubilities vary greatly, but you'll tend to notice no matter what solvent, the higher the temperature, the more solubility it is. A few solids are actually less soluble at high temperature. Just a few, okay? And I'll show you how to find those on these graphs, on these solubility curves we're going to look at. Alright, notice though a gas, increasing the temperature usually decreases solubility of a gas in a liquid, okay? So it's a little different if we're talking about a gas solvent or in a liquid solvent. Okay, this right here is an example of a solubility curve. This graph represents the relationship between solubility and its temperature. Again, notice if this is 100 grams of water, and look at the specific temperatures. Notice these are all in Celsius, not Kelvin right now. But if you look at it, I want you right now to look at this NaCl line for me, okay? If you look at it, notice it doesn't go up very much. Its solubility stays right between 30 and 40 grams per 100 grams of water, no matter if it's 0 or 100 degrees Celsius, okay? Anywhere, like if I ask you what the solubility was at 40 degrees, you would find 40, find where it intersects, and run back. That's about 30, I'm going to say 37 grams. It would be about 37 grams there. But what if I said something like I pour 60 grams of salt, NaCl, in, and I'm at 90 degrees Celsius? Well, you need to check both of those. At 90 degrees, it's saturated at 40. So if I've got 60 in, if I pour 60 grams in, that would be what we would call supersaturated, okay? It's above the saturation line. But what if instead I had said that we didn't have 60 grams? What if I had said we only had 20 grams? Notice there, still at 90 degrees Celsius, I'm below that NaCl line. So there I would be unsaturated. Okay, now that's talking about specifics there. If you look on here, you'll use these graphs on your homework to figure out if the solutions are saturated, on the line, okay, saturated is on the line, directly on any of these lines for any of these solutions. Unsaturated is below the line, and supersaturated is anywhere above the line. That will be the hardest part for you guys to figure out. Now, on here, you also need to know that this is per 100 grams of water. So what if I told you we had 200 grams of water? If we had 200 grams of water, I'm going to change colors again. I'm going to go with red now. If we had 200 grams of water, you would take the numbers from these graphs and you would double them. So say I asked again about the 40 degrees Celsius, but now I want to look at, let's see, the lead nitrate here. At 40 degrees, how much would dissolve? Well, that'd be about 75 grams of lead nitrate. But that's in 100 grams of water. If I put it in 200 grams, it'd be like 75 over 100 is equal to what? Over 200. Well, you can see you just multiply it by 2. So it'd be about 150 there. Okay? Don't stress too much over that. Those questions won't count too much against you on your homework, but you do need to be able to read these, okay? So if you have questions, I need you to email me. Let's go on. Alright guys, your homework is set 12.2. Make sure you do all of them. I'll tell you now number 3 and number 6. Number 10 and 11, these are all not going to count against you, okay? These will not count against you, but do try your best, okay? If you have any questions, email me. I'll put my email address right up here at the top. I've already had a few guys email me about chapter 11, which I love. That lets me know that you guys are working on your homework sets. And if you need me, I'm here. Thanks, guys. Good luck.